Okay, Unit 6, Lesson 2 is working with tape diagrams. So what you see here, this big rectangle, is called a tape diagram. So this is normally an assignment that we work in groups on. But with the situation that we're given this year, things are a little different, so we're just going to discuss it as a group. So on number 1, it says May made 50 flyers for 5 volunteers in her club to hang up around school. She gave 5 flyers to the first volunteer, 18 flyers to the second volunteer, and divided the remaining flyers equally among the 3 remaining volunteers. So each box here represents a volunteer. So the first volunteer that she gave 5 flyers to is our first box. The second volunteer got 18 flyers. And then there were 3 more volunteers, so she split them all equally. So that means that each of these boxes represent the same number of flyers, which is why they are all 3 labeled with X. Because once X equals a number, then each X equals that same number. And I know that when I add the flyers from all 5 volunteers together, I would get 50 flyers. So using the tape diagram, we have to determine how many flyers each of the remaining volunteers received. So I know how to do 5 plus 18, so I could do that first. So 5 plus 18. Well, that gives you 23. So the first 2 volunteers had 23 flyers. So how many was left to distribute between the 3 remaining volunteers? Well, I know that I have 50 total flyers, and the first 2 volunteers have 23 of those. So that leaves me with 27 flyers. I don't know why it keeps erasing. So that means between the 3 volunteers, I had to evenly distribute 27 flyers. So how would I determine the number of flyers that each of those 3 volunteers received? Hey, I would just divide by 7. Divide by 3. 27. 27 divided by 3. Which would be 9. So that means that each of the 3 volunteers received 9 flyers. So then if I wanted to check it, I could just do 5 plus 18 plus 9 plus 9 plus 9. And that should give me 50. And number 2 says to thank her 5 volunteers, May gave each of them the same number of stickers. Then she gave them each 2 more stickers. Altogether, she gave them a total of 30 stickers. So since we still have 5 volunteers, our rectangle is split into 5 smaller rectangles. And she gave them all the same amount of stickers, and we know this because each box says Y plus 2. So since they are all the same size and have the same label, that means they all represent the same amount. So there are multiple ways that you can solve this. I know that each box is the same, and 5 of those boxes gives me 30 total stickers. So one method would be to divide 30 divided by 5. And that would tell me that each volunteer received 6 stickers. So each of these rectangles represents 6 stickers for each volunteer. Since we have a variable, we need to know what Y equals. Well, we know that Y plus 2 must equal 6. So there comes the additive inverse property that we've previously been using. So if I add negative 2 to both sides, 2 plus negative 2 We know that equals 0. And 6 plus negative 2 is 4. So y equals 4 would be our solution for this problem. And each volunteer received 6 stickers. On number 3, May distributed another group of flowers equally among the 5 volunteers. Then she remembered that she needed some flowers to give to teachers. So she took 2 flowers from each volunteer. Then the volunteers had a total of 40 flowers to hang up. So first we need to figure out how many flowers each volunteer has. So we have 5 volunteers. Each of our rectangles is the same size with the same label. So I know that I could evenly divide. 40 divided by the 5 volunteers means that each small rectangle represents 8 flowers. But I need to know what W represents. So I know W represents the number of flowers that each volunteer had before May took 2 flowers. So then I could just solve. So W minus 2 equals 8. Again, they have the additive inverse. So I can add 2 to both sides. There's a negative 2, positive 2, which I know equals 0. And 8 plus 2 equals 10. So that means originally the volunteers had 10 flowers each, and then after May removed the 2 flowers from each volunteer, they were left with 8 flowers each. 2.3, every story needs a picture. So it's giving us some more stories, and we have to draw a tape diagram to represent that story. So on number 1, it says Noah and his sister are making gift bags for a birthday party. Noah puts 3 pencil erasers in each bag, and his sister puts X stickers in each bag. After filling 4 bags, they have used 44 items. So I know once I draw my rectangle that I'm filling 4 bags, so I need to have 4 sections. Okay, we know that the total of this tape diagram represents 44 items. We also know that Noah puts 3 pencil erasers in each bag. So here's his 3 pencil erasers. And his sister puts an unknown number of stickers in each bag. So we got to add her stickers to each bag. And we know that there's a total of 44 items. So it wants you to describe how you would find any unknown amounts in the stories. So we know 3 plus a number is in each bag. And when we combine all 4 bags, we have a total of 44 items. So since all 4 of my rectangles represent the same amount, then I can evenly divide. 44 divided by the 4 bags tells me that each bag has 11 items. So each of these bags have 11 items. And I know 3 of those 11 items are pencil erasers. So we have 3 plus X equals 11. And I know I could rewrite this as 11 minus 3 equals X. 11 minus 3, which is 8. So that tells me that his sister put 8 stickers in each bag. And once joined with Noah's 3 pencil erasers, each gift bag had 11 items. On number 2, Noah's family also wants to blow up a total of 60 balloons for the party. Yesterday they blew up 24 balloons. Today they want to split the remaining balloons equally between 4 family members. So yesterday's amount plus what they do today all has to equal 60 balloons. Messed up there. So yesterday there was 24 balloons blown up. And then I know the remaining balloons were split between 4 family members. So now I need to have 4 equal sections. In each of these sections, although mine is not quite equal, each of these sections represent the same amount because it said they were splitting them equally. And all of this total is 60 balloons. So if they've already blown up 24, we need to figure out how many more balloons they need to blow up. So they need a total of 60, and they've blown up 24 already. So that tells me that there are 36 balloons left to blow up. And of those 36 balloons, I need to split those equally between 4 family members. So I just need to know how many balloons each family member will get. So there's 36 balloons, 4 family members. So that tells me that each family member will get 9 balloons. So my X equals 9. Number 3, Noah's family bought some fruit bars to put in the gift bags. They bought 1 box each of 4 flavors. The boxes all had the same number of bars, but Noah wanted to taste the flavors and ate 1 bar from each box. There were 28 bars left for the gift bags. So we know that after Noah eats the bars, we are left with 28. And there are 4 flavors each. I don't know how many bars come in each box, so I will just start that with a B for box. So the total in each box. But then Noah ate 1 from each box. So I have to remove 1 from each box. And once I remove that 1 from each box, we now have 28 bars left. So we need to know how many bars there were originally. Again, 4 rectangles that are all the same size and represented by the same labels. So 28 divided by 4. Which is 7. So that means each of these rectangles represents 7 bars. So B minus 1 equals 7. So what minus 1 equals 7? So we could add 1 to both sides. That leaves me with B. And then 7 plus 1 is 8. So my B represents 8, which was 8 bars in each of the boxes. Originally, before Noah tasted and ate 1 of each. So the lesson 2 summary just talks about how tape diagrams are useful when we represent how quantities are related. There are times that you might not can figure out how to use a tape diagram, and that's totally okay. You may not want to use a tape diagram because sometimes they're not going to be easy to use when we have a bunch of parts that are not all equal, or something is, happening to each of those parts. But if you are a visual learner, then tape diagrams are really awesome because you're able to visualize what you're trying to figure out, and you're able to see that without just trying to imagine it in your head. So we're going to work with tape diagrams a little bit, but like I said, eventually as we move on, you're not going to be required to show your work with the tape diagrams constantly or anything like that. You'll eventually be able to move on to work the problem how you feel most comfortable. I just want to make sure that everyone has learned all the skills possible in order to be able to solve problems efficiently.